So here's another example of how we can take advantage of the normal curve in trying to estimate or calculate certain aspects. And in this case, we're talking about the proportion of fruit flies that either fall below a certain number, above a certain number, or kind of in between two numbers. So this is the one that we worked on in class. So it should look familiar, but I'm just going to walk through it again. So this is a common fruit fly. They were measuring the length of the thorax in male fruit flies, and they determined that the curve was relatively normal. So right then and there, I'm just going to draw it out, the normal curve. And they said that the mean was 0.8 millimeters, and the standard deviation is 0.078. So let's put that information in. So here's the mean, and they're saying that that is 0.8. is really what they have. So now I'm going to also write it over here. So the mean is 0.800. The standard deviation is 0.078. So I have all my facts written down. So now let's look at the questions. So what proportion of flies have a thorax that's less than 0.6 millimeters? So some of the key words here are less than, and then of course the actual value, 0.6. So I look at this and I say, okay, well I can draw that, right? I'm trying to erase that. I can draw that, so I'm going to do that now. So 0.6 is less than our mean. So 0.6 is going to be somewhere over here. And what they're asking us to calculate is the area that's less than that. So we're looking at, this is really what we're trying to figure out. What's the percentage or proportion that fall at or below 0.6. So in doing that, the first thing that I notice is that it's to the left of our target value. So that's good because we don't have to do any extra work because, as you know, that the z-scores in the table, in the appendix, assume that everything is to the left of the target. So now I know the 0.6. I know what I'm looking for. So now all we have to do is solve it. So when I solve it, now I need a z-score because I know that I'm looking for a proportion, which means I'm looking for a cumulative proportion. So I know I have to find z. And we know that z is equal to x minus the mean over the standard deviation. So I'm going to plug the numbers in. So x in this case is this 0.6, because that's the target that we're looking at, minus 0.8 over 0.078. And if I take out the handy-dandy calculator, I can do the math here. So 0.6 minus 0.8, that's going to be a negative number, so that's negative 0.2, divided by 0.078 is negative 2.56, roughly. Now we only have to go out 2 decimal places, mainly because in this case it doesn't really, that's really, the tables only go out 2 decimal places, so I mean we could get really accurate with it, but we're not going to do that for this exercise. So negative 2.56 is the number. Okay, so I just brought up the table A in the appendix, and I'm going to look now for negative 2.56. So first I look in the Z column, and I look for negative 2.5, which is right here. And then I look for the 6, which is up on the top part here. So the 0.6, where these two intersect, is my proportion, which is 0. So the proportion is 0.0052, or otherwise known as 0.52%. And if you're wondering why I always put a 0 before the decimal point, it's really just for clarity. I was taught to be a scientist, and we always put a 0 before the decimal point. So it just makes it much more clear that there's actually a decimal point there. Anyway, so this is part A. So part A we've just completed. Now let's look at part B. So I'm just going to erase some of this here. Just need to get a big eraser here. I'm just going to erase these things here, just so that things are clear. And I'm actually going to erase this part of the drawing here as well. Or it looks like I might end up just redoing the drawing. So let me just get rid of these, and we'll start fresh. So I'm going to go back to my pen, not make it so thick. Okay, so let me just fix this. So now the next question, part B, is what proportion of the thorax length have a thorax length greater than 0.9 millimeters? So now we're looking at something different. So 0.9 is to the right of this 0.8. We know that just, numerically. So this is going to be x equals 0.9 millimeters. And they're asking what proportion is greater than that. So we know now that we're looking for the stuff to the right. So this is a little different because, again, the appendix assumes that you're looking for everything to the left. So we're going to have to do an extra step for this particular problem. So let's do some work here. So I know my x, and I'll do it in the same color just so that you can match it back to the diagram. So x is 0.9, that's our target, and we're actually looking for x to be greater than 0.9, so all of those cases, the proportion. So again, we're going to be doing the same thing as before, except I'll show you where things kind of go a little bit differently. So let's start working the problem. So we're going to do exactly the same thing. We know what the x is. We know the mean and the standard deviation, so we can figure out z. And z, again, is x minus mu over sigma, standard deviation. So x is 0.9. The mean is 0.8 over the standard deviation, which is 0.078. And if we do the math on that, and I'm doing it real time here, so 0.9 minus 0.8 should be a positive number, so it's 0.1 divided by 0.078. And we get 1.28 is our number. So that's z. Now we need to actually figure out the proportion. So I'm going to go to the handy-dandy z table, which we don't want that one. We actually want the positive one now. So here's my positive z table here. And you can see we're going to look for 1.2 in the z column here. So 1.2 is here. And then we're going to go over to the 8, which is here. And if we meet where these two intersect, I'm trying to line up my rows here. I believe it's the 0.8997. So the proportion is 0.8997 or 90%. And I'm rounding up. But we didn't calculate what we're looking for. We calculated this. So this red is 90%. I'm draw a little arrow there. And this is why, because we use the table. To get the other side, I just need to figure out what plus 90% is going to get me to 100. And the obvious answer here, that's nice and easy, is just 10%. So the answer to part B is 10%. Have a thorax length greater than 0.9. So 10% have thorax, greater than 0.9. Okay, so the last piece of this is, part C, is what proportion have a thorax length between 0.6 and 0.9? So in this case, we're going to be looking at two pieces. We're going to be looking at the 0.6, which is here, and we're also going to be looking at the 0.9 here. And we're looking for the proportion that falls here. So in the previous example, in the two previous parts of the problem, we actually calculated these, and I'm just gonna, I've forgotten what the numbers were, but I'm just gonna, I think it was 0. For the first one it was 0. Whoops, that's a bad color, sorry. Let me just pick a darker color here. This one was 0.52%, and then this one was 10%, I believe. So when we did that calculation, you know that the 0.52%, 0.52% was for thorax lengths less than 0.6. So this 0.5% dealt with this part right here. The 10% dealt with this piece right here. So it's a natural progression to say, okay, I know the two tails, what the percentage is, so whatever gets all of these numbers to add up to 100 is what is going to represent the middle here. So this is going to be 100% minus 0.52 plus 10. I'm adding the two tails up and subtracting from 100 because I know that everything has to add up to 100. And so if I do the math on this, I'm going to get 0.52 plus 10, and I'm going to do 100 minus 10.52, so 100 minus 10.52, and that is roughly 89%. So 89% of the population in this study had a proportion or had a length between 0.6 and 0.9 millimeters.